Now, welcome, Nazmi. So, I'm Felix. Super cool project at Felix, right?
Thank
Going
you.
to revolutionize forklifting without forklift, right?
Yeah, let's call it intralogistics. Yeah, we'll
Right.
revolutionize.
So, without further ado,
Yeah,
just surprise us. So, let me share your screen.
sure,
Your
sure.
screen is live. Your
Okay, yeah, you see my screen. I think it's
Yeah,
perfect.
we do.
Yeah.
So,
Hello,
floor is yours.
everyone.
Good luck.
I'm Nazmi from Filics, and we are from Munich. And sorry that actually we're not there in person, but this is also good to have the opportunity to share and talk about what our vision is, what we do at Filics. So I'm actually not the person that should be maybe presenting this, but Marcus was not available, so I had to jump in for this meeting. So what we do at Felix, I will start. We reshape intralogistics. And what I do there is I usually do actually computer vision in Felix, but I will explain you what we do and what we try to achieve with our product. So when you rethink the forklift, we want to make this process somehow automated, flexible, and more intelligent. So that's why we produce an AMR that you can see in this picture, for example, that's automated and consumes a lot of less space, which makes it more flexible, and it's quite intelligent. And here I can show you actually with a video, it's so much better what we do. It's a simple transporting of a load carrier with our skids. Unfortunately, I cannot show the real skids in operation due to some non-disclosure things, but there we go. So as you see, the robots come underneath, and then with the minimalistic move, they can transport pallets in the warehouse. Yeah, let's move to that. If I can move to the next slide. That would be good. Yeah. Okay, and sorry for this. Somehow it's not working. Perfect. And why are we better? So there are a lot of automations doing this, trying to automate intralogistics. There are a lot of companies, but what makes us different is actually we are breaking the intralogistic barriers. We are introducing new processes that we can do with this minimalistic size of our robots, and I will also talk about what else we do in the next slides. But for example, in this example, you can see if you had a big forklift, then it wouldn't be possible to pick up this red pallet and then take it somewhere. But with our skids, this will be possible while the skids go through the first pallet here, and then they will move to the red pallet, and then they will pick it up, basically. And we also want to shape truck loading and unloading, make it really fast. And this is one of the areas where in the warehouses, basically companies lose a lot of time. With the big forklifts, you have to go in there one by one and then take everything in. But here maybe you get a glimpse of our robots working together. This is our vision, where they bring the pairs of robots, bring the new pallets, and then they automatically go inside the truck, and then they just leave, basically, because they are so minimalistic and they can leave through between the pallets. And we basically want to make this process really fast. Let's move to the next slide. I'm somehow having a problem with my presentation. Yeah, here. So Felix, that's why it goes the extra mile and does different things compared to the other processes out there, companies out there. For example, automation is done by most of the intralogistic AGVs and AMRs out in the market today. But what our difference is that we are the most compact unit. That's why we can do movements that are not really possible in small areas in warehouses, which is a which is important actually to save space in a warehouse so you can put more things inside. And we also provide greatest flexibility. And what I mean by this is that with the defined algorithms we have, we can detect and find different type of load carriers and then carry them around, basically. And we are not constrained to doing one specific type of pallet. And with this better processes example, as you see the pallet in the middle, the load carrier can be picked up by our robot. This is, for example, one of the processes we give. Now, about talking, before coming to Zenoh, I will come to Zenoh where we use it. And I would like to talk about the technical roadmap. So in unit 1, we wanted to do, and we did, just simply move one pallet from one place to another. And this has been done already, and then we are showing this in the customer use cases. And as a next step, we want to do block storage operations and line storage operations. What I mean by that is the picture you're used to now is picking the block as a whole and then moving the blocks, or picking them one by one and then picking them from different locations. Basically, this is what we can provide. And afterwards, we want to move to swarm operations, where we can move the blocks of pallets together, and then they will quite much autonomize the transshipment process. Maybe some people are not familiar with the transshipment process. So more normal, in a warehouse, there's the section where we have to take the workers, have to take and from one truck to the other one, which then transports things between the cities. This is a tedious process if you have to do it one by one, of course. And then if you imagine this autonomized, then it's quite time saving actually. And as the last step, as our vision, we want to be able to fully autonomously load the truck and unload it. Here I also give a full video of our vision, the Filics warehouse vision. I will just start the video. Here you see our autonomous robots working together to carry around different pallets and at the same time load trucks. And this warehouse, as you see, is working completely autonomously. And this is actually closing the horizontal automation gap. But for this, as you see in this video, we have a lot of robots working together. And as some other robotics companies before me explained, when you use ROS2, the native DDS option is kind of actually not an option for you, because there's the discovery delay, it's so slow, and then you have to really communicate reliably, especially in our case with a quite real-time operation. And this is quite important because we also have two skids and they also need to communicate between the two. That's actually where Zenoh comes into play when I move here. So why do we use Zenoh? We were using native DDS, and this is actually not really scalable. And when we go do pilots in the warehouses, the network quality is especially bad. And for this, we have to introduce some sort of different way to distribute the topics that we need for our robots to run reliably, basically. And as Rodrigo before me explained, this is costing a lot of, in terms of CPU and networking, a lot of energy to you. That's why we wanted to move with Zenoh and then highly optimize what we want to distribute between, and actually just get rid of this overhead of discovery traffic. And how we do that? At the moment, we do this with Zenoh Bridge DDS, this bundle tool, and it's quite useful for us. I don't have a diagram to show it, but we run in each of our skids Zenoh Bridge DDS with the topics that we want to communicate between. This could be services, this could be topics, could be a lot of things actually. And with the help of Zenoh Bridge DDS, basically, then we can run in a quite poor network area, and we make sure that we have the correct data between the robots, because they really need to know each other and where they are and etc. And what's next, if you move to what you want to do next, is recently our CTO has visited, I think, ZettaScale, you will remember, and he discovered there as well that this Zenoh Bridge Rose 2 DDS. So we will move to Zenoh Bridge Rose 2 DDS, where I believe the RVIS is more reliable, as far as I understand. We will move to that, and we got some quite good insights on our use case, what we can use. For example, at the moment we use UDP discovery, but we want to try the quick as it was suggested to us. We will do that. And so Zenoh is going to be in our life for sure for a long time, and we are actually quite happy with it, and we would like to also contribute later when it comes to it. We had, if I remember correctly, one issue with the QoSs in ROS 2, but we were sure that also like the help from Julian was quite there, that he told us what we can do regarding these solutions, and we want to also try later in between Zenoh router and basically group the robots together, like how Rodrigo showed in between. At the moment, we don't use the Zenoh router. We just run Zenoh Bridge DDS with the corresponding IPs of the robots. And this works well for us, actually. But later, we will try those. And with this, so in general now, this is one of the things that, of course, we have to do to make sure the communication between our robots is really well, because they will be working together in the warehouse. And we have been in production now, I'm not production, building the tech for 4 years now, and research and development is still taking place, but nonetheless, we started doing market projects, and we are partnering with, at the moment, with warehouse stakeholders, and they have the potential to get 1,000 units from us. I think there are 8 or so companies in this regard, our partners, and we are doing POTs and POCs with them. And Zenoh is helping us quite a bit there, especially in the warehouse when the network is not so good. And yeah, so with that, thank you for listening. And if you have any questions, please feel free to reach out. And I don't know if you guys heard me through all this presentation, I hope, because it was
Yes, it was, I think, very good presentation. So thank you very much, Nazmi.
Yeah.
So let's thank Nazmi.
Thank you for listening.
And, best of luck with moving forward with Filics, because your project is super cool, right?
Yeah, thank you. I'm sure we will be in touch.
So I was expecting to see you with a shirt.
Yes, I have the shirt, but the thing is, it's so cold here, and I didn't bring it. I have the shirt, and I use it.
Cool. And so, yeah, we were discussing some interesting things with Marcos. And
yes.
Anyway, so looking forward to experiment some of those.
Yep.
Very cool. Okay, so hold on as we welcome Yadu and Franco. Hello, Yadu. Oh, beautiful t-shirt, Yadu. I love that.
I had to.
Hello, Franco. How are you guys?
Doing great. How are you?
Great, thank you. So we are now, across multiple continents, because Franco, you are calling from the beautiful Argentina, isn't it?
That's correct, yeah.
Yeah, and Yadu, you are based in Singapore.
That's right, Angela.
Yeah, so great. Okay, so Nazmi, again, thank you very much.
Thank you, and
yeah,
I will look for the questions on the social platforms.
online. Great.
Yeah.
Let me phase
Now,
you out.